Hello, friend, and welcome back to Science for Sleep. Tonight, we're resting gently with astronomy, not as a field of equations or distant instruments, but as an ever-evolving fascination of our night sky. Something that begins right where you are now, standing, sitting, or lying still on Earth, with the sky slowly revealing itself above you. Long before astronomy had a name, humans noticed the stars simply because they were there. When daylight faded and the atmosphere softened into darkness, tiny points of light appeared, steady and patient. Earth's atmosphere allows visible light from distant stars to pass through, filtering out much of the harsher radiation, leaving behind a calm canopy that feels almost intentional. On clear nights, thousands of stars can be seen with the unaided eye, each one shining because nuclear fusion deep within its core releases energy that travels across space as light, eventually reaching this small, quiet planet. The sense of wonder that follows is not something learned. It seems to arise naturally, without effort. Human vision is especially sensitive to contrast in low light, and as the eyes adjust to darkness, faint stars emerge gradually rather than all at once. This slow reveal encourages stillness. The mind does not rush. It waits, noticing patterns, spacing, and gentle differences in brightness. From Earth's surface, the sky appears vast but orderly, changing slowly enough that it feels dependable. Astronomy, in its earliest form, was never about leaving Earth. It was about staying, about watching how the stars rise and set as the planet turns, how certain groups return night after night, and how others shift with the seasons. Earth's rotation causes the sky to appear to move, even though it is the ground beneath us that is turning. This subtle motion, unnoticed by the body, creates a quiet illusion of a universe in motion while we remain at rest. If you enjoy these quiet journeys, I invite you to subscribe, and if you feel comfortable, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. For now, you can let the pace slow even further, allowing your thoughts to loosen without needing to hold on to anything at all. What matters here is not memorizing names or distances. It's the simple fact that curiosity begins naturally when we look up. From Earth, the stars do not demand attention. They wait. They shine at a steady brightness because, on human timescales, stars change very little. Their lifespans stretch across millions or billions of years, making their presence feel constant, almost reassuring. And so, astronomy begins not with exploration, but with presence. With being on Earth, beneath a sky that has been watched for as long as humans have had eyes to see. There's nothing you need to solve or understand right now. Just the sense that wondering is allowed to be gentle, and that it's enough to be here, looking outward from a place that feels solid and safe. The curiosity that draws attention upward does not begin with thought. It begins in the body, quietly, through the way human senses respond when daylight fades. As night settles in and artificial brightness softens or disappears, the eyes begin a gradual adjustment process known as dark adaptation. Over the course of roughly 20 to 30 minutes, the retina shifts its balance, relying less on cone cells, which detect color and fine detail in bright light, and more on rod cells, which are far more sensitive to faint light. This biological shift allows distant stars, previously invisible, to slowly come into view. Because rod cells are especially attuned to contrast rather than color, stars appear not as richly detailed objects, but as simple points of brightness against a dark background. This simplicity matters. The human visual system is remarkably good at detecting small differences in brightness and spacing, even when information is limited. When the sky darkens, the eyes naturally begin scanning, not with urgency, but with curiosity, noticing which points shine more steadily, which flicker slightly, and which seem to hold their position as the minutes pass. This process happens without instruction. There is no need to decide to observe the sky. The sensory system does the work on its own, quietly gathering information and passing it along to the mind. The lack of sharp edges, fast motion, or sudden change allows attention to settle rather than tighten. Unlike many daytime environments filled with movement and noise, the night sky presents very little that demands reaction. Its stillness invites passive observation, a state in which curiosity can exist without effort. From a scientific perspective, this gentle noticing is supported by the way stars behave across short timescales. Although stars are moving through space at tremendous speeds, the distances involved are so vast that their positions relative to one another appear fixed during a single night, or even across a lifetime. This apparent stability gives the sky a quiet consistency. Patterns can be recognized, remembered, and returned to, without fear that they will vanish. The Earth itself plays an important role in shaping this experience. Our planet's atmosphere scatters shorter wavelengths of light during the day, creating a bright blue sky that hides most stars from view. At night, with the sun below the horizon, this scattering diminishes, and the darkness allows starlight to stand out. The same atmosphere that shields life from harmful radiation also moderates the night sky, preventing it from becoming overwhelmingly sharp or harsh. Because of this balance, the sky reveals itself slowly, rather than all at once. As minutes pass, more stars appear, as though the universe is unfolding in stages. This gradual unveiling aligns naturally with the human nervous system, which tends to relax when changes occur gently rather than suddenly. There is no single moment when the sky becomes complete. Instead, it deepens, encouraging patience without requiring focus. Over countless generations, this repeated experience shaped how humans related to the night. Long before formal astronomy existed, people noticed that certain stars always appeared together, that some rose shortly after sunset during particular times of year, and that others were visible only in certain seasons. These observations did not require advanced tools, only the willingness to look, night after night, from the same stable position on Earth. In this way, the human attraction to the stars is less about seeking answers and more about responding to conditions that favor quiet awareness. The sky does not compete for attention. It simply offers itself to perception, allowing curiosity to arise naturally, without pressure, without expectation, and without the need to do anything more than remain still and let the eyes continue adjusting to the dark. Once the eyes have settled into the dark and the stars begin to feel familiar, another quiet realization emerges. The sky does not change randomly. Night after night, the same stars return, rising from the horizon and drifting across the darkness in paths that feel steady and predictable. This repetition is one of the most important reasons astronomy could exist at all. Without it, the sky would feel chaotic, difficult to trust, and harder to remember. The apparent motion of the stars is created by the rotation of Earth. As the planet turns once every 24 hours, the sky seems to move in the opposite direction, carrying stars from east to west in smooth arcs. This motion is so consistent that, even without understanding the cause, early observers could rely on it. Certain stars would always appear in roughly the same place at the same time of night, providing a dependable rhythm that quietly anchored human attention. Because this motion unfolds slowly, it rarely draws urgent notice. Instead, it encourages a kind of background awareness. The body remains still while the sky appears to glide overhead, reinforcing the sense that Earth is a stable platform from which observation can occur safely. Even though the surface of the planet is moving at hundreds of meters per second due to rotation, this movement is constant and unaccelerated, which is why it goes unfelt. The lack of sensation allows the experience to remain calm, almost meditative. Over longer timescales, the repetition becomes even more apparent. Stars rise a little earlier each night as Earth progresses along its orbit around the Sun. This shift, amounting to roughly 4 minutes per day, causes the nighttime sky to change gradually across the seasons. Constellations associated with winter give way to those of spring and summer, then return again the following year. This slow cycling builds familiarity without monotony, offering variation within a dependable structure. From a scientific perspective, this predictability comes from the immense distances separating stars from Earth. Although stars are moving through space independently, their distances are so great that their relative positions change only imperceptibly over thousands of years. This creates the illusion of a fixed celestial backdrop, sometimes called the celestial sphere, a mental model that helps describe how the sky appears from Earth, even though no physical sphere exists. The human mind is especially responsive to repeating patterns. Neuroscience shows that predictable environments require less active monitoring, allowing attention to soften rather than sharpen. When patterns are detected and confirmed over time, the brain reduces alertness and increases a sense of safety. The night sky, with its reliable motions and recurring arrangements, naturally supports this shift. This is why people across cultures, separated by geography and history, all notice the same stars and cycles. Without communication or shared language, they independently recognized repeating shapes and movements, assigning meaning to what was most stable. The sky became a calendar, a compass, and a quiet backdrop for reflection, all because it behaved in ways that could be trusted. Even now, with modern understanding, the repetition remains soothing. Knowing that the stars follow paths shaped by gravity and motion does not diminish their calm presence. If anything, it deepens it. The sky continues to offer the same gentle reassurance it always has, that some things move slowly, return reliably, and ask nothing from us in return. And from Earth, resting beneath it all, noticing these patterns feels almost effortless, as though curiosity itself is being carried along by the same steady rhythm that guides the stars. Long before astronomy became a discipline with instruments and written records, it existed as something quieter and more instinctive. Early humans did not need to label what they were doing when they looked at the sky. They simply noticed it, returning to the same view night after night, slowly recognizing that the darkness above was not empty, but structured. This kind of attention did not arise from a desire to measure or explain, but from familiarity. The sky was always there, and over time, it became known. Without telescopes or calculations, observation relied entirely on memory and repetition. People remembered where certain stars appeared in relation to the horizon, how some rose shortly after sunset, while others lingered near the edges of night. These observations accumulated gradually, passed along through stories, rituals, and shared experience. From a scientific standpoint, this was the earliest form of longitudinal study. The same phenomena were observed across many nights, seasons, and generations, allowing patterns to be confirmed through consistency alone. One of the most important discoveries to emerge from this slow attention was the link between the sky and time. Certain stars and star groups appeared at predictable points in the year, coinciding with changes on Earth such as shifts in temperature, rainfall, or animal behavior. This connection was not mystical at its core. It was a result of Earth's orbit around the Sun, which causes different regions of the sky to be visible at night throughout the year. Long before orbital mechanics were understood, this relationship was recognized simply because it repeated reliably. The human mind is well suited to this kind of learning. Rather than requiring immediate explanation, it excels at noticing regularity over long intervals. Cognitive science shows that repeated exposure to stable patterns strengthens memory without conscious effort. In the context of the night sky, this meant that knowledge could accumulate without writing, tools, or formal instruction. The sky taught itself slowly by remaining the same. What made this possible was the remarkable stability of stellar light. Stars emit energy through nuclear fusion in their cores, a process that allows them to shine steadily for millions or billions of years. On human timescales, this steadiness creates the impression of permanence. A star seen by one generation would look nearly identical to their descendants centuries later. This continuity allowed early observers to trust their observations, reinforcing the sense that the sky could be relied upon. Because of this trust, attention could relax. There was no urgency to understand everything at once. The sky was not something that needed to be conquered or solved. It was simply part of the environment, as familiar as the ground beneath one's feet. Curiosity unfolded at its own pace, shaped by the slow rhythm of nights and seasons, rather than by questions demanding immediate answers. Even myths and symbolic interpretations, often associated with early astronomy, were grounded in careful observation. While the stories themselves varied widely across cultures, the stars they described were the same. This reflects an important scientific truth. Human interpretation may differ, but the underlying phenomena remain constant. The sky served as a shared reference point, quietly linking distant communities through identical experiences of light and motion. In this early stage, astronomy was not separate from daily life. It was woven into it, existing in the background of evenings and long nights. Looking up did not interrupt rest. It often accompanied it. And in that calm space between activity and sleep, curiosity found a natural home, free from pressure, content to return again tomorrow, knowing the sky would still be there, unchanged and waiting. As nights passed and observations quietly accumulated, another gentle pattern became impossible to ignore. The sky did not remain exactly the same throughout the year. While some stars returned night after night, their timing slowly shifted, and entire sections of the sky appeared to trade places as months went by. This change was not sudden or dramatic. It unfolded so gradually that it could only be recognized through patience and memory, the same tools that had guided curiosity from the beginning. The underlying reason for this seasonal transformation lies in the way Earth is oriented in space. Our planet does not spin upright. Instead, its axis is tilted by about 23.5 degrees relative to its orbit around the Sun. This tilt is responsible for the changing seasons on Earth, influencing how sunlight is distributed across the surface throughout the year. At the same time, it determines which portion of the sky is visible at night during different seasons. As Earth travels along its yearly path around the Sun, the nighttime side of the planet faces different directions in space. In winter, the night sky points toward one region of the Milky Way, while in summer it faces another. This slow turning of perspective means that constellations associated with colder months gradually disappear from the evening sky, replaced by those of warmer seasons. The process is so steady that it rarely feels like change at all. Instead, it feels like a quiet rotation of familiarity. From a scientific viewpoint, this predictable shift offered early observers a powerful form of orientation. Even without knowing the cause, people learned that the appearance of certain stars signaled particular times of year. The sky became a gentle calendar, marking the passage of time not through numbers, but through light and position. Because the pattern repeated annually, it could be trusted, reinforcing the sense that the universe operated according to slow, understandable rhythms. The human mind responds especially well to this kind of gradual variation. Research in perception shows that slow, cyclical changes are less likely to trigger alertness or stress. Instead, they promote a feeling of continuity. The seasonal sky does not surprise the observer. It transitions smoothly, allowing attention to drift along with it rather than react. This changing view of the heavens also reinforced the idea that Earth itself was part of a larger system. Though early observers did not conceptualize orbits or axial tilt, they recognized that the sky's behavior was linked to the passage of time on Earth. Nights grew longer or shorter. Certain stars appeared earlier or later. These connections quietly suggested that the ground beneath one's feet and the lights overhead were not separate experiences, but parts of the same unfolding process. Importantly, these changes did not disrupt the sense of stability that made observation restful. Even as the sky evolved across the year, it did so within narrow bounds. The same stars returned each year, following nearly identical paths. This balance between change and repetition kept curiosity engaged without overwhelming it. There was always something slightly new to notice, yet nothing felt unfamiliar enough to require effort. In this way, Earth's tilt added depth to the sky without disturbing its calm. The heavens became dynamic without becoming chaotic. From one season to the next, the stars offered subtle reminders that time was passing, while still holding on to the comforting knowledge that everything would come back around again. And from the surface of Earth, quietly turning through space, this slow dance of light and perspective could be observed without moving at all, simply by being present beneath a sky that was always, gently, becoming something new. As the sky revealed itself night after night, certain groupings of stars began to stand out, not because they were physically connected, but because the human mind naturally looks for structure. When scattered points of light appear against a dark background, perception tends to link them together, forming shapes that are easier to remember than isolated dots. This tendency is a well-studied aspect of visual cognition. The brain is efficient, preferring patterns that can be stored and recalled with minimal effort. Constellations emerged from this quiet process. Scientifically, the stars within a constellation are rarely close to one another in space. Some may be dozens of light years away, while others lie hundreds or even thousands of light years beyond that. They only appear grouped because they are seen from the same vantage point on Earth. This perspective effect turns depth into flatness, allowing unrelated stars to seem connected when viewed against the distant background of space. Despite this lack of physical connection, constellations served an important observational role. They acted as mental landmarks, helping observers navigate the sky with ease. By identifying familiar shapes, people could track where objects rose, how they moved, and when they returned. This made the sky feel organized rather than overwhelming. Instead of countless individual stars, there were recognizable regions that could be revisited again and again. From a scientific standpoint, this organization supported early astronomical understanding. Constellations provided reference frames long before coordinate systems existed. They allowed observers to describe the positions of the moon, planets, and other transient objects relative to fixed patterns. Even today, modern astronomy still uses constellation boundaries to map the sky, a reminder that these ancient mental groupings continue to serve a practical purpose. The human mind finds comfort in these familiar shapes because they reduce cognitive load. Studies in perception show that known patterns require less active processing than unfamiliar ones. When the sky is divided into remembered forms, attention can relax. There is no need to scan endlessly or analyze every detail. Recognition does the work quietly, freeing the observer to simply rest in the experience. Importantly, constellations also change slowly over time, reinforcing their usefulness. Because stellar positions shift only very gradually due to proper motion, the shapes remained recognizable across many lifetimes. This long-term stability meant that knowledge could be shared across generations without distortion. A shape learned in childhood would still appear much the same decades later, providing continuity in a changing world. While different cultures traced different figures among the same stars, the underlying process was identical everywhere. Humans responded to the same visual environment with the same instinct to organize it gently. The stories varied, but the stars did not. This highlights a subtle scientific truth. The sky offers consistent information, and the human perceptual system meets it in consistent ways. In this sense, constellations were never about imposing meaning onto the universe. They were about making observation feel approachable. By turning vastness into something familiar, they allowed curiosity to linger without strain. From Earth's surface beneath a sky too large to grasp all at once, these simple shapes offered just enough structure to make looking up feel calm, inviting, and easy to return to, night after night, without ever needing to understand more than was comfortable in the moment. Once the sky felt familiar through repetition and recognizable shapes, another layer of curiosity quietly emerged. Not all stars behaved the same way. Some shone more brightly, others appeared faint and distant, and a few seemed to vary subtly from night to night. At first, these differences were simply noticed, not explained. Brightness was an experience before it was a measurement, and distance was a feeling long before it became a concept. For a long time, it was natural to assume that brighter stars were closer, while dimmer ones were farther away. From an everyday perspective on Earth, this assumption makes sense. Nearby lights appear stronger than distant ones. In space, however, brightness is influenced by two factors at once: how much light a star produces, and how far that light must travel before reaching Earth. A very luminous star can appear bright even from an immense distance, while a smaller, dimmer star may be quite close, yet still appear faint. This realization took time to unfold because stellar distances are difficult to sense directly. Stars are so far away that, when viewed from Earth, their positions appear almost unchanged even as the planet moves around the Sun. This effect, known as parallax, is extremely small for most stars. Only the nearest ones show a detectable shift against the distant background over the course of a year. Early observers could not measure this movement, but they could sense that the sky behaved differently from familiar earthly spaces. From a scientific perspective, this challenge highlights the scale of the universe. Even the closest star system beyond our own lies more than 4 light years away, meaning its light takes over 4 years to reach Earth. At such distances, depth becomes difficult for human perception to resolve. The sky appears like a flat dome, not because it is flat, but because the distances involved exceed what the visual system evolved to interpret. The human mind responds to this ambiguity not with alarm, but with quiet curiosity. When depth cues are limited, the brain often shifts into a more contemplative mode, observing without attempting immediate resolution. This is one reason the night sky can feel both vast and calming at the same time. There is no demand to understand scale intuitively. The experience remains gentle, even when the reality behind it is immense. Over time, as tools improved, astronomers learned to measure stellar distances using careful observation rather than direct sensation. By tracking tiny shifts in position and analyzing the properties of starlight, scientists began to map the three-dimensional structure of nearby space. These methods revealed that the stars forming familiar constellations were scattered across enormous volumes, separated by distances so large that their apparent closeness was purely a matter of perspective. Yet even with this knowledge, the visual experience remains unchanged. The stars still appear as points of light on a dark canvas, offering no immediate clues about how far away they truly are. This disconnect between perception and reality is part of what makes astronomy uniquely gentle. The universe does not overwhelm the senses with its scale. It allows understanding to arrive slowly, through patience rather than force. In this way, the slow discovery of distance did not disrupt the calm relationship humans had with the sky. Instead, it deepened it. Knowing that stars are spread across unimaginable expanses adds quiet weight to their steady presence. From Earth, looking outward, there is no pressure to grasp the full scale all at once. It is enough to notice that some lights are brighter than others, and to let that small observation open the door to a universe that reveals its depth only when one is ready to linger with it, without urgency, beneath the same familiar sky. As understanding slowly expanded outward, one thing remained constant. All observation began from the same place. No matter how distant the stars or how vast the universe became in thought, the experience of astronomy always started on Earth. This grounding presence is easy to overlook, yet it shapes everything about how the sky is perceived. We do not float through space while observing. We remain firmly anchored, supported by a planet that turns gently beneath us. From a physical perspective, Earth provides a remarkably stable platform. Its gravity holds the atmosphere in place, allowing light from space to pass through in softened form. Without this atmosphere, the sky would appear harsh and stark, with no gradual transition between day and night. Instead, scattering and absorption smooth the experience, giving twilight its long fade and allowing the night sky to arrive slowly rather than abruptly. This gradual shift encourages observation without strain. The planet's rotation also plays a crucial role. As Earth turns, the sky appears to move, yet the body feels no sensation of spinning. This is because the rotation is steady and constant, producing no acceleration that the inner ear can detect. The result is an unusual experience where immense motion exists without any feeling of movement. The stars glide overhead while the observer remains physically still, reinforcing a sense of calm detachment. Scientific instruments may extend perception, but they do not change this fundamental arrangement. Even the most powerful telescopes remain rooted to Earth or orbit closely around it. Data is always collected from a position that shares the planet's motion through space. Every image, spectrum, and measurement is shaped by Earth's orientation, atmosphere, and movement, reminding us that observation is always relational rather than detached. The human mind seems to benefit from this stable reference point. Cognitive studies suggest that environments with a consistent physical frame reduce the need for constant recalibration, allowing attention to soften. When the ground beneath you feels steady and predictable, it becomes easier to explore mentally without feeling unmoored. The night sky, vast as it is, does not provoke disorientation because the body remains at rest. Even as knowledge of the universe grows, this bodily experience does not change. Understanding that Earth orbits the Sun at tens of kilometers per second does not alter the quiet feeling of standing beneath the stars. The discrepancy between scale and sensation creates a unique kind of peace. Immense motion exists, but it is filtered through stability, allowing curiosity to expand without triggering unease. This relationship between stillness and movement is one of astronomy's most gentle qualities. You do not need to chase the universe to observe it. It comes to you through light, arriving patiently after traveling vast distances. Earth receives this information calmly, night after night, offering it to anyone willing to look up. In this way, Earth is not merely a starting point for astronomy. It is an essential part of the experience itself. The planet's quiet reliability allows observation to feel safe, contained, and unhurried. From its surface, curiosity can wander far beyond familiar limits, while the body remains grounded, supported, and still. And as long as that balance remains, the act of looking outward will continue to feel less like exploration and more like rest, carried gently by a world that knows how to hold us while the sky slowly passes overhead. Among all the lights in the night sky, one stands apart through its closeness and familiarity. Long before distant stars were studied or patterns were named, attention was naturally drawn to the moon. It moves differently, changes shape, and appears large enough to feel almost within reach. From Earth, it is the most noticeable celestial object after the Sun, and for much of human history, it served as the first reliable reference point beyond the planet itself. Scientifically, the Moon is Earth's only natural satellite, orbiting at an average distance of about 384,000 kilometers. This proximity makes it appear far larger in the sky than any star or planet, even though many of those objects are vastly bigger in physical size. Its closeness also means that changes are easy to notice. The Moon's phases unfold over roughly 29.5 days, a cycle driven by its orbit around Earth and the changing angles of sunlight reflecting from its surface. These phases offered an early lesson in predictable motion. Unlike stars, which maintain nearly constant brightness, the Moon visibly transforms, shifting from a thin crescent to a full circle and back again. This regular change provided one of the earliest natural timekeepers. Lunar cycles were observed and remembered long before calendars existed, linking the sky to rhythms on Earth such as tides, planting, and rest. The Moon's influence is not only visual. Its gravitational pull interacts with Earth's oceans, creating tides that rise and fall with remarkable consistency. This connection between a distant object and physical movement on Earth reinforced the sense that the sky and the ground were part of the same system. Even without understanding gravity, early observers could see that the Moon's position mattered, shaping the world in subtle, repeating ways. From a perceptual standpoint, the Moon offers something rare in astronomy: scale that feels intuitive. Surface features such as dark plains and bright highlands are visible to the naked eye, providing texture rather than points of light. This makes the Moon easier for the human mind to engage with, as it presents a recognizable form rather than an abstract sparkle. Familiarity builds quickly, and with it, a sense of quiet companionship. Despite its closeness, the Moon remains distant enough to maintain mystery. Its surface is shaped by ancient volcanic activity and countless impact craters, records of events that occurred billions of years ago. Because the Moon lacks a thick atmosphere, these features remain largely unchanged, preserving a visible history that Earth itself no longer displays so clearly. In this way, the Moon becomes both near and deep in time, bridging immediacy and vastness. The Moon's steady presence also helps frame the rest of the sky. Its path across the stars changes slightly each night, revealing that not all celestial motion follows the same patterns. This distinction laid the groundwork for later understanding of orbits and planetary movement, even though such concepts would come much later. Through all of this, the Moon remained gentle in its role. It did not demand explanation. It simply offered itself as a reference, returning again and again in familiar cycles. From Earth's surface, its light softened the darkness, making the night feel less empty and more inhabited. And in that quiet glow, curiosity found an anchor, a nearby companion in the sky that made the vastness beyond feel approachable, steady, and calm enough to continue observing without hurry, night after night. As attention moved beyond the Moon and toward the broader sky, a subtle paradox emerged. Everything above appeared to be in motion. Yet nothing about the experience felt hurried or unstable. Stars rose, crossed the darkness, and set again, all while the observer remained completely still. This quiet contrast between visible movement and physical rest is one of the most distinctive features of astronomy as experienced from Earth. The explanation lies in the nature of motion itself. Earth rotates once every 24 hours, carrying its surface eastward at significant speed. At the equator, this movement reaches over 1,000 kilometers per hour. Yet because this rotation is constant and unchanging, the body does not register it. The inner ear detects acceleration, not steady motion. Without acceleration, there is no sensation of movement, allowing Earth's rotation to remain unnoticed. As a result, the sky appears to move instead. Stars trace slow arcs across the night, circling a point near the celestial pole. This apparent motion is so smooth that it often goes unnoticed moment to moment, becoming visible only through patience. Long exposures in photography reveal these paths as gentle curves of light, visual proof of motion unfolding without disturbance. Earth's orbit around the Sun adds another layer to this stillness. While the planet travels through space at roughly 30 kilometers per second, this movement also remains unfelt for the same reason. The speed is constant, and the forces involved are balanced. From the surface, there is no vibration, no rushing sensation, only continuity. The universe changes position around us, yet the experience remains calm. The human mind responds uniquely to this kind of motion. Environments where change occurs smoothly and predictably tend to lower cognitive load. There is no need to track sudden shifts or react quickly. Instead, attention drifts, observing motion as background rather than event. The sky becomes something to rest with, not something to follow actively. Scientific instruments confirm this gentle reality. Measurements of stellar positions show precise, continuous movement, driven by Earth's rotation and orbit. Yet these changes are so regular that they can be predicted centuries in advance. Predictability transforms motion into reassurance. When movement follows a known rhythm, it ceases to feel disruptive. This relationship between motion and stillness may help explain why watching the sky can feel grounding rather than disorienting. Even though the scale of movement is enormous, the lack of sensory disruption allows the nervous system to remain relaxed. The body trusts the environment because nothing unexpected occurs. In this way, astronomy reveals that movement does not have to imply urgency. Change can unfold quietly without calling attention to itself. From Earth, motion becomes a soft backdrop rather than a demand. The stars glide by, the planet turns, and the universe continues its steady unfolding. All while the observer remains at rest, supported by a world that knows how to move without being felt, and a sky that demonstrates how vast motion can coexist with deep, unbroken calm. Even in the quiet of night, the sun remains central to everything that unfolds in the sky. Though it is no longer visible, its presence is still felt through the rhythms it sets and the light it has left behind. The cycle of day and night itself exists because of Earth's relationship with the sun, and astronomy, at its foundation, is shaped by this steady interaction between a single star and the planet that orbits it. Scientifically, the Sun is a medium-sized star composed mostly of hydrogen and helium. Deep within its core, nuclear fusion occurs continuously, where hydrogen atoms combine to form helium, releasing energy in the process. This energy travels outward over long periods of time before finally reaching space as sunlight. By the time it arrives at Earth, that light has been softened and spread, warming the planet gently and making life possible. The reliability of this process is what gives the Sun its anchoring quality. Fusion within the Sun proceeds at a remarkably stable rate, allowing its brightness to remain nearly constant over human timescales. This stability creates predictability. Days follow nights, seasons repeat, shadows move in familiar patterns. Long before clocks or calendars existed, these cycles provided a dependable structure for human experience. The Sun's apparent motion across the sky is another result of Earth's rotation. Each day, it rises in the east, reaches its highest point, and sets in the west, tracing the same broad path with subtle seasonal variations. These changes occur because of Earth's axial tilt, causing the Sun's arc to grow higher or lower depending on the time of year. The result is a slow, graceful modulation, rather than abrupt change. Even when it is hidden below the horizon, the Sun continues to shape the night. Twilight occurs because sunlight scatters through the atmosphere even after the Sun has set, creating a gradual transition rather than a sharp divide between light and dark. This extended fading allows the eyes and the nervous system to adjust slowly, preparing perception for the stars that follow. The human mind responds well to such consistency. Neuroscience suggests that predictable environmental cues help regulate internal rhythms, including sleep and alertness. The Sun's regularity provides a temporal framework that the body comes to expect, reducing uncertainty and supporting a sense of stability. In this way, the Sun influences not only astronomy, but the very rhythms of human experience. In the broader context of the universe, the Sun is only one star among hundreds of billions in the Milky Way. Yet from Earth, it holds a unique role. Its proximity makes it powerful enough to shape climate, energy, and time, while its steadiness allows it to fade into the background of daily life rather than dominate attention. When night arrives and the Sun's light gives way to starlight, the transition feels natural rather than dramatic. The same star that illuminated the day quietly hands the sky over to others. This continuity reinforces the sense that the universe operates through gentle exchanges rather than abrupt shifts. And from Earth, resting beneath this rhythm, the Sun remains an unseen anchor, holding everything in place, allowing curiosity to drift outward while the foundation beneath it stays warm, familiar, and calm. As the stars settled into familiar patterns and the Sun defined the rhythm of days and seasons, a small group of lights quietly set themselves apart. These points did not hold their positions night after night. Instead, they moved slowly against the background of stars, tracing paths that shifted over weeks and months. Early observers noticed this difference without needing to explain it. These lights behaved unlike the rest of the sky, and that alone made them worthy of gentle attention. Scientifically, these objects are planets, bodies that orbit the Sun rather than shining by their own light. Their visibility comes from sunlight reflecting off their surfaces or atmospheres. Because planets move along their own orbits while Earth moves along its own, their positions relative to the stars change over time. From Earth's perspective, this creates motion that feels deliberate and distinct, slower than the Moon, yet more noticeable than the stars. some planets follow paths close to the same region of sky traced by the Sun and Moon, an area known as the ecliptic. This shared path made them easier to track, as they appeared among familiar constellations. Over time, careful observation revealed that their movement was not uniform. At certain points, a planet would appear to slow, stop, and even reverse direction temporarily. This effect, called retrograde motion, is not caused by planets actually changing direction, but by the relative motion between Earth and the planet as both orbit the Sun. To the human mind, this wandering quality added intrigue without disrupting calm. The movement was slow enough to be noticed only through patience, encouraging long-term observation rather than quick reaction. Each shift unfolded over days or weeks, reinforcing the idea that the sky rewards lingering attention. The behavior of planets also offered an early lesson in layered motion. While the stars formed a stable backdrop, planets demonstrated that not everything followed the same rules. This contrast gently expanded understanding without overwhelming it. The sky remained orderly, but not rigid. There was room for variation within an overall sense of balance. Modern astronomy confirms that planets are shaped by gravity and inertia, moving along predictable paths governed by physical laws. Yet these laws express themselves softly when viewed from Earth. There are no sharp turns or sudden changes, only gradual curves traced through space. Even complex interactions resolve into smooth motion when observed across sufficient time. Because planets reflect sunlight rather than emit it, their brightness can change depending on their distance from Earth and the angle of illumination. This variability added another layer of quiet curiosity. A planet might grow brighter over weeks, then fade again, offering subtle changes that rewarded attention without demanding it. In this way, planets became gentle reminders that the universe is dynamic without being chaotic. Their slow wandering added depth to the sky, inviting curiosity to follow along at its own pace. From Earth, watching these distant worlds shift against the stars does not feel like chasing movement. It feels like being allowed to notice change as it happens naturally, guided by rhythms that unfold slowly enough to remain restful, predictable, and calmly absorbing, night after night. As curiosity deepened and patterns became familiar, a quiet question emerged. How could anything so distant be known at all? The stars and planets were far beyond reach, untouched and unmoved by human presence. Yet understanding continued to grow. Astronomy became unique among sciences because it relied almost entirely on observation rather than direct interaction. Knowledge came not from handling objects, but from receiving what they offered freely in the form of light. Light carries information across space with remarkable consistency. When energy is released from a star, it travels outward as electromagnetic radiation, moving at a fixed speed through the vacuum. By the time it reaches Earth, it holds subtle clues about its origin. Different elements absorb and emit light at specific wavelengths, leaving recognizable patterns known as spectral lines. These patterns allow scientists to determine what stars are made of without ever approaching them. This process does not require intrusion. Instruments simply collect light and spread it into its component colors, revealing these signatures quietly and precisely. From Earth, a telescope does not disturb what it observes. It waits. It gathers. The information arrives on its own schedule, shaped by distance rather than by effort. This passive exchange reinforces the calm nature of astronomical discovery. Distance itself becomes part of the measurement. Because light takes time to travel, observing faraway objects means seeing them as they were in the past. A star 1,000 light years away is observed as it existed 1,000 years ago. This effect, called look-back time, allows astronomy to function as a form of natural history, recording earlier states of the universe without excavation or disturbance. The human mind responds differently to this kind of knowledge. There is no sense of intrusion or urgency. Information arrives already complete, requiring only patience and interpretation. Cognitive science suggests that learning based on observation rather than action tends to feel less demanding, allowing curiosity to remain open rather than strained. Even motion can be measured this way. Small shifts in the wavelength of light, caused by an object moving toward or away from Earth, reveal velocity through the Doppler effect. These shifts are minute, yet they can be detected with precision, allowing astronomers to track motion across vast distances without ever witnessing it directly. Importantly, these measurements reinforce the idea that the universe is not hidden or guarded. It reveals itself continuously, offering clues through light that travels uninterrupted for years, centuries, or longer. Nothing needs to be forced into view. Understanding grows by listening rather than reaching. From Earth, this method of knowing feels especially gentle. The observer remains still while the universe speaks through faint signals arriving from far away. There is no pressure to act quickly or intervene. The process unfolds at a pace set by the cosmos itself. In this way, astronomy demonstrates that knowledge does not always require closeness. Sometimes distance provides clarity. By learning to read light rather than touch matter, humans found a way to understand the universe without disrupting it. And from the surface of Earth, quietly receiving these messages, curiosity is allowed to deepen, while the body remains at rest, simply noticing what has traveled so far to arrive, intact and waiting, at the edge of perception. As the understanding of light deepened, the need to see more clearly followed naturally, not out of urgency, but out of patience. Telescopes did not emerge as tools of conquest or ambition. They appeared as quiet extensions of human vision, designed to gather more of what was already arriving. Light that had traveled immense distances simply needed a wider opening through which it could be received. At their most basic level, telescopes work by collecting light over a larger area than the human eye can manage alone. By using lenses or mirrors, they concentrate faint light into a focused image, allowing distant objects to appear brighter and more detailed. This does not magnify the universe in the way the word might suggest. Instead, it increases sensitivity, making subtle signals easier to notice without changing their nature. Early telescopes revealed that the sky was richer than it appeared unaided. Stars once seen as single points resolved into clusters. The hazy band of the Milky Way separated into countless individual suns. Even these early discoveries reinforced a calming truth. The universe did not become harsher or more chaotic when seen more clearly. It became more detailed, layered, and quietly abundant. Modern telescopes follow the same principle, only refined. Large mirrors collect enormous amounts of light, allowing astronomers to observe objects so faint that their glow barely rises above background darkness. Some telescopes detect wavelengths invisible to the human eye, such as infrared or radio waves, revealing processes that occur behind dust clouds or across vast regions of space. Yet even these instruments remain passive. They do not send signals outward. They wait and receive. From a scientific perspective, this method preserves continuity. Observations made with telescopes still depend on Earth's position, motion, and atmosphere, unless the instrument orbits nearby. Even space-based telescopes remain close companions to the planet, circling within Earth's gravitational influence. The act of observing remains grounded, tied to the same reference point that has always shaped human experience of the sky. The human mind often responds positively to tools that extend perception without increasing demand. Telescopes do not speed up understanding. They slow it down, allowing faint details to emerge gradually. Studies of attention suggest that environments encouraging sustained, low-effort focus promote calm awareness rather than cognitive strain. The telescope supports this by revealing more without requiring faster processing. Importantly, telescopes did not replace direct experience. The naked eye sky remained meaningful and complete on its own. Instruments simply added depth, offering additional layers for those who wished to linger longer. There was no obligation to use them. Curiosity could remain gentle, choosing how far to extend itself. In this way, telescopes became companions rather than disruptors. They allowed humanity to look farther without leaving Earth, to see more without forcing interpretation. Light still arrived at its own pace, shaped by distance and time, and the observer remained still, receiving it quietly. From the surface of Earth, with the planet turning beneath and the sky unfolding above, telescopes serve as reminders that seeing more does not require reaching outward. Sometimes it only means opening the eyes a little wider and waiting. And in that waiting, curiosity continues its calm expansion, supported by tools that respect stillness and by a universe that reveals itself patiently, one faint signal at a time. As vision extended and details multiplied, another realization settled in slowly. The universe was not only detailed, it was vast in a way that resisted intuition. Distance in space does not behave like distance on Earth, and the numbers involved quickly grow beyond anything the human mind evolved to picture. Yet this realization did not arrive as a shock. It unfolded gently, because the sky itself never forces scale upon perception. In astronomy, distance is often measured in light years, a unit that describes how far light travels in 1 year. Light moves at a constant speed of about 300,000 kilometers per second, covering enormous distances without pause. Even so, a single light year is vast, spanning nearly 10 trillion kilometers. When distances between stars are described this way, they begin to make sense scientifically, even if they remain abstract experientially. The nearest star system beyond our own lies just over 4 light years away. Within the Milky Way, stars are separated by distances that commonly reach dozens or hundreds of light years. The galaxy itself spans roughly 100,000 light years across, containing hundreds of billions of stars arranged in a flattened, rotating structure. These facts describe scale accurately, yet they do not overwhelm the senses, because none of this size is directly visible from Earth. the night sky compresses this immensity into something manageable. Points of light remain points of light, regardless of how far they have traveled. This compression acts as a natural buffer, allowing curiosity to approach scale gradually rather than all at once. The universe does not announce its size visually. It allows understanding to arrive slowly, through context rather than confrontation. From a psychological perspective, this gentle presentation matters. Research into cognitive load shows that information becomes stressful when it exceeds the capacity for mental integration. Astronomy avoids this by separating experience from explanation. You can look at the sky without needing to calculate distances. Knowledge deepens quietly in the background, while perception remains calm. Scientific models help bridge this gap without demanding imagery. Astronomers describe structure through relationships rather than pictures, explaining how gravity shapes galaxies and how stars cluster within them. These explanations offer coherence without requiring the mind to visualize every scale simultaneously. Understanding becomes layered, not forced. Importantly, this vastness does not diminish Earth's place. Knowing the size of the universe does not make the observer feel smaller in experience. From the surface of Earth, the sky remains the same gentle canopy it has always been. The scale exists intellectually, not sensorially, allowing awe to coexist with comfort. In this way, the scale of space becomes something that can be approached without urgency. It is present for those who wish to think about it, and invisible to those who simply wish to rest beneath the stars. The universe does not insist on being comprehended in full. It allows curiosity to stretch as far as it feels natural, then stop, content to remain grounded on Earth, while knowing that beyond what can be seen, there is room enough for thought to wander without ever needing to grasp the whole at once. As distance became easier to accept, another quiet dimension revealed itself alongside it. Space was not only wide, it was deep in time. Light, which had always served as the messenger between the universe and Earth, carried more than brightness or color. It carried history. Every point of light in the night sky arrived with a delay, shaped by the time it took to travel across space. Scientifically, light moves at a constant speed through the vacuum, covering about 300,000 kilometers each second. This speed is immense by everyday standards, yet space is larger still. When light travels for years before reaching Earth, it turns distance into time. A star observed at 10 light-years away is seen as it existed 10 years ago. More distant objects are seen as they were centuries, millennia, or even billions of years in the past. This effect, known as look-back time, means that astronomy is not simply a study of where things are. It is also a study of when they were. Telescopes do not show the universe as it exists right now everywhere at once. They reveal a layered record, with nearby objects appearing relatively recent and distant ones, offering glimpses into much earlier stages of cosmic history. The sky becomes a kind of archive, arranged not by pages but by distance. The human mind does not naturally experience time this way. On Earth, time feels immediate and continuous, marked by internal rhythms and external cues like light and shadow. Cosmic time unfolds differently, stretching beyond lived experience. Yet the sky presents this vast temporal scale gently. There are no signs announcing how old a photon is when it arrives. It looks the same whether it has traveled for seconds or eons. This subtlety protects the observer from overwhelm. The experience of looking remains simple, even as understanding deepens. Knowledge of cosmic time does not demand emotional response. It sits quietly behind perception, offering depth without pressure. Cognitive studies suggest that abstract time, when detached from urgency, tends to evoke reflection rather than stress. Astronomy naturally supports this reflective state. Stars themselves embody long timelines. Their lifespans stretch across millions or billions of years, far exceeding human history. When their light reaches Earth, it represents a moment within that long existence, preserved and delivered without distortion. Even stars that have already changed or faded may continue to shine in the sky for ages afterward, their light still on its way. From Earth, this creates a gentle sense of continuity. The sky connects present experience with distant past, without requiring the observer to hold both at once. You can simply notice the light, knowing that it has traveled patiently, unchanged by the time it took to arrive. In this way, time becomes something that does not rush. The universe reveals its history slowly, one photon at a time. From a quiet place on Earth, receiving that light does not feel like witnessing ancient events. It feels like being included in an ongoing exchange, where the past arrives softly into the present, asking nothing more than to be seen, and allowing curiosity to rest comfortably within a moment that stretches far beyond itself, without ever needing to feel the weight of it all at once. With time written into light itself, attention can rest gently on the stars as more than fixed points. Each one is living through a long, gradual process, unfolding over spans of time so extended that change becomes almost invisible. Stars are not permanent fixtures. They are dynamic systems, quietly evolving according to physical principles that operate patiently rather than dramatically. Scientifically, stars begin their lives within clouds of gas and dust known as nebulae. Over long periods, gravity causes regions within these clouds to draw together, slowly increasing in density and temperature. When conditions become sufficient, nuclear fusion ignites in the core, and a star begins to shine. This process does not happen suddenly. It unfolds over hundreds of thousands or millions of years, making the transition gentle on cosmic scales. Once fusion begins, a star enters a long, stable phase in which it converts hydrogen into helium. For most of its life, a star changes very little in brightness or size. Our own sun has remained in this steady phase for billions of years, and it will continue to do so for billions more. This stability is what allows stars to feel constant and reliable when observed from Earth. Their lifetimes are so long that, within a human lifespan, they appear unchanging. Different stars follow different paths depending on their mass. Smaller stars burn their fuel slowly, shining faintly, but enduring for extraordinary lengths of time. Larger stars burn more brightly and live shorter lives, using up their energy more quickly. These differences shape the night sky, influencing which stars appear most prominent and how long they remain visible across cosmic history. Despite these varied paths, stellar evolution proceeds without urgency. Even dramatic events, when they occur, unfold over timescales that soften their impact when viewed from afar. The universe does not rush its processes. It allows matter and energy to transform gradually, maintaining a sense of continuity rather than disruption. The human mind finds comfort in this slowness. Research into perception shows that systems characterized by long-term stability promote feelings of predictability and safety. Stars exemplify this principle. Though their internal processes are powerful, their outward behavior remains calm and steady, offering a consistent visual environment night after night. From Earth, the knowledge that stars are living through vast cycles does not change how they appear. They remain points of light, steady and patient. Understanding their life histories adds depth without altering experience. The sky does not demand awareness of stellar evolution in order to be appreciated. In this way, stars become quiet companions across time. They remind us that change does not have to be fast to be meaningful. Growth, transformation, and completion can occur slowly, almost imperceptibly, without urgency or strain. And from Earth, watching these distant lives unfold through faint, steady light, curiosity is free to linger without pressure, content to observe processes so gradual that they feel less like events and more like a continuous, calming presence woven gently into the fabric of the night sky. As attention moves beyond individual stars, a broader structure begins to emerge, one that exists on scales far larger than any single light. Stars are not scattered randomly through space. They gather into vast systems, shaped slowly by gravity, forming patterns that unfold over millions of years. From Earth, these structures are not immediately obvious. They reveal themselves only through patience and perspective, reinforcing the idea that the universe favors gradual understanding. The most familiar of these structures is the Milky Way galaxy, the faint band of light that stretches across the night sky. To the naked eye, it appears as a soft, cloudy glow, brighter in some regions and dimmer in others. This glow is created by the combined light of countless distant stars, so densely packed along the galaxy's plane that individual points blend together. The effect is gentle rather than sharp, offering a reminder that abundance does not always announce itself loudly. Scientifically, galaxies are collections of stars, gas, dust, and dark matter bound together by gravity. The Milky Way alone contains hundreds of billions of stars arranged in a flattened disk with a central bulge. Yet from Earth, this immense structure is experienced as a subtle presence rather than an overwhelming one. The sky does not reveal its full architecture at once. It offers hints, allowing the mind to accept scale slowly. Beyond individual galaxies, even larger patterns exist. Galaxies group together into clusters, and clusters form vast filaments separated by enormous voids. This arrangement, sometimes called the cosmic web, arises from the influence of gravity acting over immense distances. Matter flows along these invisible pathways, shaping the universe into a structure that is both intricate and remarkably calm in its evolution. What makes these patterns especially soothing is the timescale on which they change. Galactic motion occurs over millions of years. Clusters drift and interact so slowly that, from a human perspective, they appear frozen. The universe feels stable not because nothing moves, but because everything moves gently, respecting a pace that does not disturb perception. The human mind tends to find comfort in large-scale order, even when details remain unknown. Psychological research suggests that recognizing overarching structure reduces uncertainty, allowing attention to relax. Knowing that stars belong to galaxies and galaxies belong to larger systems creates a sense of coherence without requiring the ability to visualize every component. From Earth, these vast patterns remain mostly conceptual. The night sky continues to present itself as points of light and soft glows, never insisting that its full structure be seen. This separation between experience and explanation allows awe to exist without strain. You can simply look up, aware that there is order beyond what can be seen, without needing to hold it all in mind. In this way, the universe offers reassurance through scale rather than intimidation. Its largest patterns unfold quietly, shaped by forces that act patiently and predictably. From a small, steady planet within this immense arrangement, curiosity is free to drift outward, knowing that beyond the familiar stars lie structures far greater than us, yet governed by rhythms so slow and gentle that they feel less like movement and more like a deep, enduring stillness holding everything together. As patterns grow larger and understanding stretches outward, it becomes important to return gently to where everything begins. No matter how vast the universe becomes in thought, every experience of it still occurs from the same place, from Earth. This is not a limitation. It is the quiet center that makes observation possible at all. Even the most advanced knowledge of galaxies and cosmic structure does not change the physical reality of looking up from the ground. Feet rest on solid surface. Air surrounds the body. Gravity holds everything in place. The stars may belong to distant systems, but perception remains local. The universe is encountered through a human body, filtered through senses shaped by life on this planet. Scientifically, this grounding matters more than it may seem. Every measurement, no matter how precise, is influenced by Earth's motion, atmosphere, and position in space. Astronomers correct for these factors constantly, accounting for rotation, orbit, and atmospheric distortion. Yet these corrections are only possible because Earth provides a stable reference frame. Observation depends on having a place to stand, even when the subject lies far beyond reach. The human mind benefits from this anchoring effect. Research into cognition shows that having a consistent physical reference reduces mental strain when processing abstract information. When the body feels secure and supported, the mind is more willing to explore concepts that extend far beyond immediate experience. Earth offers that security quietly, without demanding attention. There is also something deeply calming about knowing that no matter how far curiosity travels, experience itself does not leave home. You can think about stars forming billions of years ago, or galaxies colliding far beyond the Milky Way, while remaining fully present in a single moment on Earth. The contrast between immense scale and personal stillness does not create conflict. It creates balance. From Earth, the sky is always framed by familiar horizons. Trees, buildings, mountains, or open land provide boundaries that help perception stay oriented. The universe appears overhead, not all around, reinforcing the sense that vastness exists above while stability remains below. This simple geometry supports calm awareness rather than disorientation. Even modern space exploration does not remove this centrality. Images sent back from probes and telescopes are still received, processed, and understood on Earth. They become meaningful only when interpreted by human perception, shaped by earthly experience. The universe may be vast, but understanding it is always a local event. In this way, Earth does not shrink as the universe expands in knowledge. It becomes more important. It remains the quiet platform that allows curiosity to unfold without urgency. The place where the body rests while the mind wanders. And as long as observation begins here, the act of looking outward will continue to feel grounded, safe, and gentle, supported by a world that stays beneath us while the sky opens endlessly above, never requiring us to leave in order to feel connected to something far greater than ourselves. As understanding deepens, it becomes clear that astronomy does not move toward a final conclusion. Instead, it opens outward, revealing layers of knowledge alongside equally vast spaces of uncertainty. This openness is not a flaw. It is one of the qualities that allows curiosity to remain gentle rather than demanding. The universe does not insist on being fully explained in order to be meaningful. Scientifically, there are aspects of the cosmos that remain only partially understood. A significant portion of the universe appears to be composed of forms of matter and energy that do not interact with light in familiar ways. These components influence the motion of galaxies and the expansion of space itself, yet they cannot be seen directly. Their presence is inferred through careful observation rather than direct detection. For the human mind, this kind of knowledge creates a different relationship with understanding. Instead of seeking closure, attention learns to coexist with open questions. Cognitive research suggests that uncertainty, when not linked to threat or urgency, can encourage reflection rather than anxiety. Astronomy offers uncertainty in a context that feels safe, distant, and unhurried. Importantly, these unanswered questions do not disrupt the experience of the night sky. Stars continue to shine. Galaxies remain structured. The observable universe behaves consistently, even as deeper explanations remain incomplete. This separation between experience and explanation allows curiosity to rest without pressure. You do not need to resolve mysteries in order to appreciate what is visible. The history of astronomy reflects this balance. Each generation has uncovered new insights while leaving others unresolved. The sky has never required full understanding to be watched, and it continues to reveal enough to satisfy attention without exhausting it. Knowledge expands slowly, layered atop earlier understanding rather than replacing it abruptly. From Earth, this openness feels natural. The sky presents itself without instructions or demands. It does not promise answers. It simply exists, offering light and motion that can be noticed or ignored, studied deeply or observed casually. The lack of obligation allows curiosity to remain soft. The human mind tends to settle when it is allowed to explore without expectation. When learning is framed as optional rather than necessary, attention relaxes. Astronomy invites this state by making its most profound questions distant and abstract, separate from immediate concerns. In this way, not knowing becomes part of the experience rather than an obstacle. The universe remains vast, structured, and partially mysterious, and that is enough. From Earth, resting beneath a sky that holds both clarity and uncertainty, curiosity does not feel compelled to reach conclusions. It can simply remain open, content to notice what is present, aware that there will always be more beyond what can be known, and comfortable with the quiet space that exists between understanding and wonder. As curiosity settles into openness, another quiet truth becomes clear. The night sky has never belonged to one person, one culture, or one moment in time. It has always been shared. Across continents, climates, and centuries, humans have looked up from Earth and encountered the same broad arrangement of light. Long before language connected people across distances, the sky offered a common experience, one that required no agreement and no explanation. Scientifically, the stars visible from Earth are shaped by geography and slow planetary motion. Latitude determines which regions of the sky rise above the horizon, and Earth's axis undergoes a gradual wobble, known as precession, subtly changing the orientation of the sky over tens of thousands of years. Yet within these slow shifts, there is remarkable continuity. Many of the brightest stars visible today were seen by observers thousands of years ago, occupying nearly the same positions relative to the horizon and to one another. This continuity matters to the human mind in a way that is difficult to articulate, but easy to feel. Psychological research suggests that shared reference points, especially those that persist across time, foster a sense of stability and belonging. The night sky offers this naturally. You do not need to know who else is watching. The mere fact that others have seen the same stars, wondered the same quiet thoughts, and paused beneath the same darkness creates a subtle sense of connection. Different cultures interpreted the sky through their own environments and stories. The same stars became different figures, symbols, or guides depending on location and tradition. Yet beneath these interpretations, the observational experience remained consistent. The sky rose and set, patterns repeated, seasons marked themselves through returning lights. This reveals an important scientific and human truth. While meaning varies, perception does not. The universe provides stable information, and the human perceptual system responds in broadly similar ways. Even without conscious awareness, the body recognizes this shared rhythm. Night falls, light fades, stars appear. These cues regulate internal states, encouraging rest and reflection, because these signals have accompanied humanity for as long as there have been humans. They feel familiar at a deep level. The mind does not treat the night sky as something new or threatening. It treats it as something remembered. In the modern world, artificial lighting and constant activity often obscure this experience, but it has not disappeared. When darkness is allowed to return, even briefly, the same process unfolds. Stars emerge. Motion becomes slow. Attention softens. The sky does not need to be learned again. It resumes its role immediately, offering the same calm structure it always has. From Earth, this shared experience does not require participation or acknowledgement. You can engage with it privately, knowing that it exists beyond individual awareness. The night sky remains a quiet meeting place, not in a social sense, but in a perceptual one. A space where countless human experiences overlap without intersecting. In this way, astronomy is woven into human history, not through discovery alone, but through repetition. The sky has been seen, forgotten, and seen again by uncountable lives. And in that repetition, it continues to offer the same gentle invitation to look up, to notice, and to rest in the awareness that wonder is not something created alone, but something shared silently beneath a sky that has always been there, waiting, unchanged enough to feel familiar, and vast enough to hold everyone who has ever looked. With the sky understood as something shared and enduring, curiosity no longer feels like a question that needs answering. It begins to feel more like a state the mind naturally settles into when conditions are right. Wonder does not need to be summoned or justified. It emerges on its own when attention is allowed to rest without pressure, and the night sky provides exactly this kind of environment. From a scientific perspective, wonder is not separate from perception. Studies in cognitive neuroscience suggest that when the brain encounters stimuli that are expansive but non-threatening, activity shifts away from rapid decision-making and toward broader, integrative awareness. The night sky fits this pattern closely. It offers vastness without immediacy, complexity without urgency. There is nothing to react to, nothing to fix, nothing to prepare for. Attention is free to remain open. This openness is why astronomy has always invited reflection rather than demand. You do not need to know the names of stars or the mechanics of orbits to feel drawn toward the sky. The experience functions independently of knowledge. In fact, too much active analysis can pull the mind away from the gentle state that wonder inhabits. The sky does not reward effort. It rewards stillness. Biologically, this makes sense. Low-light environments naturally reduce sensory overload. Fewer visual details compete for attention, allowing perception to widen rather than sharpen. The absence of sudden motion or loud sound signals safety to the nervous system. Over time, this combination encourages a relaxed attentional mode, one in which curiosity feels spacious rather than focused. This is why wondering about the universe often feels different from solving a problem. Problems ask for resolution. Wonder asks only for presence. When the mind is allowed to drift across the sky, noticing light without labeling it, the experience becomes self-sustaining. There is no need to reach a conclusion or store information. The act of noticing is complete on its own. Importantly, this state does not depend on scale. Whether one considers a single star or the entire cosmos, wonder arises from the same quiet conditions. The universe does not need to be fully imagined to be felt. Even a few visible stars are enough to activate this expansive awareness. The rest can remain unseen without diminishing the experience. From Earth, this natural wonder is supported by familiarity. The sky is not foreign. It has been present throughout human evolution, shaping rhythms of rest and attention long before scientific explanation existed. Because of this, the mind does not treat it as an intrusion. It recognizes it as part of the environment, one that signals it is safe to slow down. In this way, wonder becomes less about astonishment and more about ease. It is not the sharp intake of breath that comes from surprise, but the long exhale that comes from recognition. The universe does not need to impress to inspire this feeling. It only needs to remain quietly available. And so, beneath the stars, curiosity finds its most natural form, not as a drive to know more, but as a permission to linger, to let thoughts stretch without direction, to allow awareness to expand without effort. Wonder does not ask for understanding. It simply arrives, settles gently into the mind, and remains there, calm and unhurried, as long as the sky is allowed to stay in view. As wonder settles into something gentle and sustained, the sense of vastness begins to feel less like a concept and more like an atmosphere. The universe no longer needs to be measured or described. It becomes something that surrounds thought without pressing in on it. Vastness, when encountered without urgency, does not overwhelm. It steadies. From Earth, the sky presents this immensity in a softened form. There are no sharp edges or clear boundaries. Darkness blends into light, and light fades gradually into darkness again. This lack of definition allows the mind to stop searching for limits. When there is nothing to mark where something ends, attention naturally relaxes. The universe feels open, but not demanding. Scientifically, this sense of openness reflects the true structure of space. There is no edge to the observable universe that can be seen directly. Instead, visibility fades with distance as light becomes fainter and redshifted. What cannot be seen does not announce itself. It simply remains beyond reach, allowing perception to rest on what is present rather than strain toward what is not. The human mind responds well to environments that do not require constant orientation. When there are no immediate tasks or threats, the brain reduces its effort to categorize and control. Studies of attention show that in such states, thought becomes more associative and less linear. This is why gazing at the night sky often leads to drifting thoughts rather than focused analysis. The environment encourages mental spaciousness. Importantly, this vastness does not remove a sense of self. Instead, it places the self gently within a larger context. From Earth, you are not lost in the universe. You are held by it. Gravity keeps you grounded. The horizon frames your view. The sky remains above, not all around. These cues maintain orientation even as imagination expands. The universe also reveals its vastness slowly. There is no sudden realization of scale when looking up. The stars do not announce how far away they are. They simply appear, one by one, as darkness deepens. This gradual unfolding allows the nervous system to adjust without alarm. Vastness arrives quietly, like a deepening silence rather than a loud declaration. Over time, familiarity replaces astonishment. The idea of immensity becomes comfortable, even soothing. Knowing that there is more than can be seen does not create pressure to see it all. It creates permission to stop trying. The universe does not need to be grasped to be felt. In this way, settling into vastness becomes an act of rest. The mind does not push outward. It opens. Thoughts slow. Attention widens. There is room for quiet without emptiness, and space without loneliness. The sky offers scale without significance attached, allowing the mind to simply exist within something larger, without needing to define its place precisely. From Earth, beneath this open expanse, vastness becomes less about distance and more about calm continuity. The universe continues beyond view, but it does so gently without calling attention to itself. And in that quiet extension, curiosity no longer moves forward. It settles. It stays. It rests comfortably within a space that feels endless, not because it must be understood, but because it does not need to be. As attention settles fully, the sky no longer needs to remain in the foreground of thought. Curiosity has done its quiet work, and now it can soften further. allowing awareness to drift without direction. The universe does not disappear. It simply recedes, becoming a steady backdrop rather than a subject of focus. This shift is natural, and it mirrors the way perception eases as the body prepares for rest. From a scientific perspective, there is nothing unusual about this fading. Human attention is not designed to remain fixed indefinitely. When stimuli are consistent and non-threatening, the brain gradually reduces active monitoring. The stars do not flicker rapidly or change abruptly. Their constancy allows attention to release them without concern, trusting that nothing urgent will be missed. The night sky supports this transition especially well. Its features are distant, quiet, and slow. There are no sudden sounds or movements to pull awareness back. Over time, the points of light blur into a general impression rather than individual objects. This is not a loss of perception, but a gentle broadening of it. The universe becomes atmosphere rather than image. The human mind responds to this by shifting inward slightly. Thoughts may become less defined, moving away from language and explanation. Neuroscience suggests that as external attention softens, internal imagery and memory may briefly surface, then dissolve as well. This is a natural prelude to sleep, encouraged by environments that offer low stimulation and high predictability. Importantly, the sky does not resist this fading. It does not demand continued engagement. Astronomy, at its most restful, allows observation to end without conclusion. There is no final fact to hold on to, no insight that must be remembered. The universe remains whether it is actively noticed or not. From Earth, this withdrawal of attention feels safe because the environment remains stable. Gravity continues to hold the body. Air remains present. Darkness stays consistent. The sky does not change its behavior when it is no longer watched closely. This reliability allows the mind to loosen its grip without fear. As awareness drifts, the vastness overhead becomes more abstract, more like a feeling than a scene. The idea of stars and galaxies remains somewhere in the background, but it no longer asks for processing. Curiosity rests, satisfied not because it has reached an answer, but because it no longer needs to ask. In this way, letting the sky fade is not an ending. It is a continuation of the same calm that began with looking up. The universe remains present, quietly unfolding beyond attention, while the mind turns inward, guided by the same gentle rhythms that have always accompanied nightfall. From Earth, held steady beneath it all, the sky does what it has always done best. It allows rest to arrive naturally, without instruction, without urgency, simply by remaining still enough to be forgotten in the most peaceful way possible. As the sky fades into the background, awareness settles more completely into the present moment. Curiosity no longer reaches outward. It returns gently to where it began, to the surface of Earth, to the quiet certainty of being held by something solid, familiar, and dependable. This return does not feel like leaving the universe behind. It feels like arriving back into the body after a long, unhurried drift. Scientifically, nothing has changed. Earth continues its rotation. The planet moves along its orbit. The stars remain where they are, sending light outward in all directions. Yet perception shifts. Attention narrows just enough to notice breath, stillness, and weight. The same physical laws that guide galaxies also keep the body grounded, pressing it softly into place through gravity that never demands awareness. The human mind often finds relief in this return to immediacy. Cognitive research shows that when attention moves away from expansive, abstract thought and toward bodily presence, mental activity slows. There is less need to organize information or maintain coherence. The nervous system recognizes that it is safe to disengage. Nothing requires response. Nothing needs to be remembered. Earth offers this reassurance constantly. Its rhythms are deeply familiar, shaped by evolution and repetition. The cycle of day and night, the pull of gravity, the quiet consistency of physical surroundings, all signal stability. Even while understanding the vastness of the universe, the body responds primarily to these local cues. The sky may inspire wonder, but Earth provides rest. This grounding does not diminish the significance of what has been observed. Instead, it integrates it. The knowledge that the universe is immense, ancient, and structured does not need to remain active in thought. It can settle into the background as a quiet context, enriching experience without occupying attention. The mind does not have to hold on to awe. Awe can remain diffuse, present without effort. From Earth, this integration feels natural. The horizon limits vision gently. Darkness reduces detail. Sound softens. The environment becomes simpler, allowing awareness to contract without resistance. The universe does not vanish. It simply becomes unnecessary to attend to. In this way, returning to Earth is not a narrowing of perspective, but a deepening of comfort. The body recognizes where it belongs. The mind follows. Curiosity rests not because it is exhausted, but because it is complete for now. Beneath the same sky that inspired quiet wonder, Earth continues to offer what it always has. A place to stand, a place to rest, a place where the vastness overhead does not press down, but remains above, distant and calm. And as attention settles fully here, supported by gravity and familiarity, the journey outward concludes gently, not with an ending, but with a sense of being exactly where you are meant to be, held steady while the universe carries on beyond thought, unobserved and untroubled, moving slowly enough to allow everything below to finally let go. Now there is nothing left to follow. No motion to track, no ideas to carry forward. The sky has done what it needed to do, and Earth has taken over quietly, guiding awareness into stillness without instruction. This is the natural conclusion of curiosity when it is allowed to unfold without pressure. It does not end in answers. It ends in calm. From a scientific perspective, stillness is not the absence of activity. The universe remains in motion. Particles move, fields fluctuate, Earth turns, the sun shines. Yet at the scale of experience, these movements are too steady to disturb rest. Stillness arises not because nothing is happening, but because nothing demands attention. The distinction is subtle but important. The human mind responds to this state by reducing effort automatically. Neural activity shifts away from planning and evaluation and toward maintenance and restoration. Thought becomes less linear. Language loosens. Images may appear briefly, then dissolve. This is not something that must be encouraged. It happens on its own when the environment supports it. The night sky has always played a role in this transition. For countless generations, darkness signaled a time to slow, to withdraw from outward focus, and to rest. Astronomy, at its most natural, aligns with this rhythm rather than interrupting it. Looking up leads not to stimulation, but to release. Curiosity opens the door, then steps aside. Earth completes this process gently. The surface beneath you remains unchanged. Breath continues without instruction. The body settles into its own weight. There is no need to revisit what was seen or understood. The universe does not require remembrance. It does not measure attention or care whether it is observed. In this final stillness, perspective becomes unnecessary. There is no need to feel small or large, connected or distant. Those ideas belong to thought, and thought is no longer needed. What remains is presence, uncomplicated and sufficient. The stars continue their steady paths. Light continues to travel. Time continues to unfold. All of it happens without your involvement, and that is what allows rest to arrive fully. Nothing is waiting for you to notice it, so you can stay here, on Earth, in the dark, with the sky above doing what it has always done, far beyond reach and far beyond concern. The journey outward has softened into quiet awareness, and now even that can fade. There is nowhere else to go, nothing left to understand, just stillness, supported by a world that moves gently enough to let you sleep, while the universe carries on in silence, unobserved, unchanged, and perfectly content to do so without you.